All right. Make sure. There it is. All right. What we're talking about today is translations. I don't know if you've watched any of the videos so far. Okay. You got the note sheets, yes? Okay. So we're just starting 1.3. So the others are there. Did we get you into Google Classroom? Okay. Okay. So all the videos so far have been posted up there. I try to record them so you can watch them. If you have questions, email me. Email me. I don't care when. As soon as you have them, email. On that note, if you do have homework questions, again, I don't mind you asking for 1.2 problem, whatever. If you want to take a picture of that problem and send it to me, that's even better. Because I can look right at it and answer the question right there. If you tell me the number, that's fine. I will find it. But normally I have to go look it up, find the problem, and then come back to it, to the email. So just a few more steps, but that's fine. Works either way. Now, this here, horizontal and vertical translation.
Just kidding. That's sad, but I've heard it, but she went to the office all the time. No, she got called to the office. Oh, she's off this week. I was like, oh my gosh.
What we're looking at today is this here, horizontal translation and vertical translation. Now, we talked about this the last 2 days, moving it up, down, left, right. Yes?
But now we're regraphing.
So now we're applying it. So we're going to be given an equation. We're given a function, and we're going to move that function up, down, left, or right. So we're going to apply it to it. Now, there is a lot of words here about these here. Now, the key thing for horizontal translation is this equation here, f of x minus h. And we'll be using this here to apply our horizontal translation, the movement to the left or right. Because by subtracting h from the inputs before evaluating the function shifts it that far. The main thing is this here, the vertical translation. The graph of y equals f of x plus k is the vertical translation of the graph of y equals f of x. And we can use that to be able to apply this transformation. Okay. So those are the 2 key equations we're going to need for horizontal and vertical translation. And we'll use these here with the amount that it's moving up, down, left, or right to apply the transformation. Now, having it in words and seeing the formula is one thing, but I've always think once we see it and how it works, we'll have a better understanding than just looking at the words. So the first one is this one here. We want to write a function g whose graph is a translation 3 units down of the graph of f. Now, G is just the letter we picked. It's the letter that the book picked. It doesn't really matter what we name it. We just need to be able to name it something that's different than what we started with. Because we need a way to distinguish our original function we started with and the one that we moved, in this case, 3 units down. We need a way to separate those two. So we're going to call the new one g of x. We could have called it h of x, z of x, q of x, s of x, any of those there. Now our movement is up and down. Our up and down is vertical. The general form, the form that we use to get this movement is our f of x plus Okay. Question? Now, could we use different things besides f of x? Well, yes. It's just what function are we applying it to? In this case, we're applying it to f of x. If we were applying a vertical translation up down to, say, z of x, it would be z of x plus k. It's just telling us which function are we applying it to. Normally, we apply it to just f of x. That's just standard form here. Now, we need to figure out what k is. K is our movement. So what would k be here? So 3 down. So the value of k is 3. Because that's our movement up, down. We're moving it down 3, yes? And since we're moving it down, would the 3 be positive or negative? Negative, because we're going down. Down is negative movement. Up is positive. Right is positive. Left is negative. And we'll deal with that here in a second when we get to horizontal. Questions on this so far? Up and right. Negative is down and left. Okay? Looks like you're questioning on the down and left. It'll make sense here in a minute. Okay. So, k is negative 3. So let's put it in its place. So we're going to place k with its value, which is negative 3. Well, normally we don't write plus negative 3. We would just write it as what? Minus 3, negative 3. Yeah, we don't put the plus minus. We just say minus. And we will do that here in a second. Now we need to replace f of x with its function. So what is f of x? Equation. 2x plus 1. Now technically what we're doing is I'm replacing every x in f of x with x. That doesn't do anything because I took the x out and put the x back in. Yeah. So this just becomes 2x plus 1. Because that's really what we're doing, but we normally just say we replace it with this function. We use just, instead of having f of x, we have 2x plus 1, yes? All right. Now we still have the plus negative 3, or we can just write it as minus 3. Questions on this so far? Is there anything in front of our parentheses of our 2x plus 1? No, so what can we do with those parentheses? We can just drop them. We don't need them. So it is 2x plus 1 minus 3. Combine like terms. Which would be, so we have g of x equals, still have 2x because 2x did not have any like terms. 1 minus 3 is negative 2. That's it. Questions on this here? Now the biggest thing with these here is taking it step by step. Because if we try to do too much all at once, it can get confusing and there's too many things moving at once. But taking this one step at a time and using these general forms are going to make these nicer to work with. So any question on our vertical, up, down? We feel good with up, down. All right. Well, let's look at some horizontal translations. So this time we want to write a function h whose graph is 2 units to the left of the function f. Well, we will have h of x. Now the general form for left and right, our horizontal, is f of x minus h. Now, I rewrote f of x back out. You don't have to. The main reason I rewrote it back out is, well, the original function for my screen is off screen, yes? So I'm rewriting it so I can refer back to it. Yours is still on your paper. You can see it right there, yes? So that's the main reason I rewrote it. So I'm not sitting there scrolling up, down the whole way through. So, questions on anything we've done so far with this here? So our movement for this one here is 2 units to the left, which means our value of h is 2, yes? Now, will that 2 be positive or negative? It is going to be negative. Now before, because again, what we said the last 2 days is that left and right is the opposite of what we think, yes? And when we're looking at it and describing the transformation, it is indeed the opposite. Because when we have the plus inside those parentheses are absolute values, the h value is actually negative. And when it's negative inside those parentheses, the h value is actually positive. So here it told us what h was. H is 2 units to the left, minus 2. Now, if I plug that value of h in, that negative 2 in, inside the parentheses, what do we have? We have x minus negative 2, yes? Do we ever, in writing equation any of this, leave a negative and a negative? No, we rewrite it as plus. Okay, that kind of still lines up with what we had yesterday. It is negative, it got that plus to go the opposite direction. So we're plugging it in, we're talking about it moving left to right. Still treat left as negative, right as positive. But when we're looking at it and describing the transformation, it does have that opposite movement. Do we kind of see the difference there? It's a small difference, but it is there. Questions on this here? We ready for the next part? Yes? So we have f of x plus 2 here, yes? Our original function was what? F of, so what do? We replace the x with x plus 2, yes? So that whole expression, yes? Which means every x in f of x has to be replaced with x plus 2. Everything else is going to stay the same. We still have the 2. We still have the plus 1. Every other part of the equation is going to stay the same. But instead of having 2 times x, we now have 2 times x plus 2. All the other properties, or all the other parts of the function f of x are still going to be there. The 2, the plus 1. The only thing we're changing is the x. Does that make sense? Are there questions on that there? There's only one x, so it's only going to be put in there once. But if we had said an x squared, we'd have x plus 2 squared, and then we'd have the other x. Every single time it shows up, it's going to be replaced with x plus 2. Now on that note, you don't have to add this, I'm just adding this in as a side note. If it was 2x squared, when we plugged it in, it'd be 2 times x plus 2 squared plus 1. All those other properties would still be there. All those other operations will still stay there. We're just replacing that x with x plus 2. So questions on how we got here? Now, this side here, h of x and f of x plus 2, they're equal. They're the same thing. So we don't have to keep writing h of x equals f of x plus 2. We could just write this as h of x, because that is our new function that's describing this change. Now on the other side, we have 2 times x plus 2 plus 1. We need to distribute the 2. So we're going to do 2 times x, which is 2x. 2 times positive 2 is positive 4 plus 1. And the last thing we need to do is combine like terms. 2x plus 5. That's it. Questions on this here? Okay. So this here, I wrote it in orange to signify that we replaced this x with this x plus 2. Because we're plugging that into the function. It's taking the place of x. Now, this is a little bit of a side note. If this helps you visualize what we're doing, awesome. If this kind of makes you more confused, just forget it, okay? Now, the way we treat function notation, what's inside is normally x. We normally write it as x. Or, it's probably been a minute.
I have your attention, please. When the bell rings, all the softball girls need to go to Coach Kendall's room. That's when the bell rings. All the softball girls need to go to Coach Kendall's room. Thank you.
We've seen it as f of 6. Because all that's saying is we plug 6 into the function and find the value. You all remember doing this a little bit? Because it's been a few years. Because whatever we plug in here, we're going to plug into the function. We're used to using a number, a letter. But really, just like the last one, because whatever goes in here is going to go in all the other spots. So if we have x in the box, the other equation has it all in x.
But you're trying to add something to the
Yeah, so if instead of having f of x, I have f of y, we fill it in where all the x's are, essentially where that box would be. And I'm not restricted on it being just x, or just a number, a letter. It can be whatever we want, because we can do x plus 1. Whatever I do to this here, we have to do it to every one that shows up on the other side. Does that make sense? Because it could be x squared minus 7x. So all the other ones would have x squared minus 7x. Doesn't matter how long or simple. When it shows up in one, it's going to show up in the rest. When we replace one, we replace the rest. And that's all it is. Are you ready to look at the next one here? Now between the two, I think going up and down is, I don't like using easy, but it's a little bit easier than left, right. Just in how it works. Now our next one here, let f of x equal 4x minus 9. Write a function, g, whose graph is a translation of 5 units up. So g of x is going to equal f of x plus k, because we use the f of x plus k because that is our general form for our translation up and down. Now for this here, our value of k is going to be what? Because we're going to go up 5, so the number is 5, and since we're going up, up is going to be positive. So it's going to be positive 5. So we have f of x plus 5. Now we can put parentheses around this at this point, but they're not going to do anything because plus 9 in front of it, we're just going to drop it. It's going to go just being 5. Questions? I did have a question at this point earlier today. Could we have plugged f of x in at this point? Yeah, there's nothing stopping us from doing that. We could do both at once if we want. Although if doing one at a time makes it easier for you to work with, do it one at a time. If you feel comfortable doing it at the same time, do it at the same time. Because our next step will be to plug in this f of x function, which is 4x minus 9 plus 5. Do we have anything in front of the parentheses? No, so we can drop them, we can get rid of them. Telling us g of x is equal to 4x minus 9 plus 5. Combine like terms. That's it. Questions on this here? You good so far? We ready for the next one? Write a function h whose graph is a translation 1 unit to the right of f. H of x equals f of, since we're going horizontal left right, we're going to use our f of x minus h. Now what would our value of h be? 1. Would it be positive or negative? So which direction are we moving? To the right. So right direction is what? Normally positive, yes? So here it is positive. If we know or are being told the direction, it's going to be as we normally interpret it. Right is positive, left is negative. If we're trying to tell the direction from the equation, that's when it's switching. Because here, right, our h value is indeed positive. Let's plug it in. Let's plug in our value of h. Because it's going to be x minus positive 1. But when we plug it in, it now looks negative. Because once it goes inside those parentheses, it's the opposite of what we think. Does that make sense?
Yes.
Because once it's in the parentheses, yeah, if it's inside the parentheses or absolute values, it's opposite of what we think. Here, 1 unit right, we're not inside the parentheses or absolute values yet. So it's exactly what we think. Inside those parentheses or absolute values, it's going to be the opposite of what we think. Does that make sense? Makes more sense, hopefully. Awesome. Because, again, that is where asking questions does help, because I can expound and clear it up if I can. Should be able to. All right. So now we have f of x minus 1. Well, our f of x was 4 times x minus 9. Yes? But we don't have f of x anymore. We have f of x minus 1, yes? Which means every x in this function f of x needs to be switched to x minus 1. So we still have the 4, but instead of multiplying it by our x, we're going to multiply it by x minus 1 minus 9. So all we did was go through and replace every x with x minus 1. Questions on this here? What's our next step? We need to get rid of the parentheses. We need to distribute the 4, yes? So we're going to multiply through by 4. First thing is going to be 4 times x, which is 4x. 4 times negative 1 is minus 9. And this is indeed our h of x. Negative 4 minus 9 is negative 13. Yeah, if we're not paying attention, we'll just start adding. I will say I've done that before when I'm not paying attention. Just add the two numbers, or really 4 minus 9. But that is our equation. Questions on this here? We ready for the last one of the day? This is the last one we're going to do. I do some of the horizontal translation, the up-down, I do find kind of funny how they work. It'll make more sense here in a minute. Now for this one here, did they tell us what we want to name the new function? No. Yeah. Yeah, we can do G. But the letter we name it is not the important piece. So we're going to say g of x. So since we're going up and down, it's going to be f of x plus k. So what is our k value for this here? 5. And since it's going up, it will be positive 5. Now, I mentioned this in the last one. We'll go on and do this here. So if we decided to replace f of x and k at the same time, let's see how that would look. So what is our f of x function? X. Okay. Plus our 5. If we want to put the parentheses, we can. Don't have to, because again, there's not a number in front of the 3x's parentheses. So it's going to become 3x plus 5. We ready for the next step? There's not one. No, there's not one. Because there are no like terms, there's nothing to combine. That's it. That's kind of why I find some of these up-down kind of comical, because really all we did was what? Slap a plus 5 on it, and we were done. Yeah. But we'll finish this on Monday.